I'm gonna give you the lowdown on the Andromeda Galaxy. It's like a superstar in the night sky. Some folks call it Messier 31 or M31, and it's a big shot in the local group gang of galaxies, which includes our very own Milky Way. You can spot it up there in the Andromeda constellation as a kinda faint, hazy patch. Size-wise, this bad boy is massive. It's got a whopping diameter of about 220,000 light-years, making it the big cheese among galaxies nearby. The Milky Way, on the other hand, is no slouch either, but it's got a diameter of only around 100,000 light-years. So, Andromeda is like more than twice as large, making it a real giant in the neighborhood. Now, the Andromeda Galaxy has a special look. It's got this cool setup called a barred spiral. Imagine a chunky center with stars, gas, and dust, surrounded by a flat disk with those majestic spiral arms stretching outwards. It's like our Milky Way's style too, so it's a big deal when it comes to studying how galaxies form and evolve. What's really mind-blowing is the insane number of stars packed into Andromeda, about 1 trillion of them. That's like 4 times the stars we've got in the Milky Way. No wonder it's so bright and easy to spot without a telescope. And get this, there are over 400 globular clusters sprinkled around Andromeda. These clusters are tight groups of stars held together by gravity, and they give astronomers tons of info about the galaxy's history and formation, as well as its interactions with other galaxies in the local group. The Andromeda Galaxy is like our close neighbor, and its size and looks have made it a rock star in astronomy circles for a long time. Learning about Andromeda not only teaches us about its own journey but also helps us compare it to our own Milky Way, giving us clues about how galaxies evolve in the universe. And here's a wild twist, the Andromeda Galaxy and the Milky Way might be on a collision course way down the road. Imagine that, a cosmic smash-up. That's why it's even more fascinating for cosmologists to study, thinking about what happens when galaxies like these crash. So, there you have it, the 411 on the Andromeda Galaxy. It's an awesome spectacle up in the night sky and a goldmine of cosmic knowledge for us curious Earthlings. Alright, let me tell you about the cosmic drama that's gonna go down when the Andromeda Galaxy and the Milky Way finally collide. It's gonna be one heck of a show. First off, these two giant galaxies are part of the local group crew, like a squad of galaxies held together by gravity. And they're not just chilling in space, they're actually moving toward each other, getting closer and closer over a super long time span. But don't expect some high-speed action movie crash. Their relative speed is about 70 miles per second, which might sound fast to us, but in space terms, it's just kinda chill. So, Andromeda is like a mind-blowing 2.5 million light-years away from the Milky Way. That's a seriously long-distance relationship right there. As they approach each other, their gravitational forces start playing a cosmic game of tug-of-war. These tidal forces start messing with their shapes, pulling and twisting their spiral arms. It's like a gravitational dance-off. As they get even closer, their gravitational forces will get too intense to resist, and they'll merge together. It's like a galactic hug. All the stars, gas, and dust from both galaxies will mix and mingle, changing their orbits and trajectories within this new cosmic mashup. The merger is gonna transform both galaxies into something completely new. Imagine a big cosmic blender mixing all their features together. The end result? A brand new, unified galaxy made from the remnants of Andromeda and the Milky Way. Talk about a cosmic makeover. During this merger, there's gonna be a whole lot of baby-making going on, stellar baby-making, that is. The interaction of stars, gas, and dust will trigger the formation of new stars and stellar clusters. It's like a stellar baby boom. And all that dust flying around will make for a seriously rich environment for star formation. It's gonna be like a stellar nursery up in there. But wait, that's not all. Both Andromeda and the Milky Way have supermassive black holes at their centers, and when they collide, it's gonna be like a black hole dance-off. Eventually, they'll merge into one massive black hole, hanging out in the center of the newly formed galaxy. Black holes partying together. This whole process is gonna take billions of years. It's like a cosmic slow cooker. The new galaxy that emerges will be a one-of-a-kind creation, with a mix of stars, gas, and structures that tell the story of the history of Andromeda and the Milky Way. So there you have it, the epic tale of the Andromeda-Milky Way collision. It's gonna be a wild ride, and the resulting galaxy will be a celestial masterpiece. Buckle up, space travelers, 'cause this collision's gonna be a sight to see. Let's take a trip back in time to explore how we came to understand the Andromeda Galaxy, or M31, as we know it today. Way back in the 10th century, a Persian astronomer named Abd al-Rahman al-Sufi was one of the first to mention Andromeda. He called it the little cloud, and thought it was a nebulous object. See, back then, astronomers didn't know about galaxies like we do now, so they usually saw nebulous things as individual stars or clusters. Fast forward to the 17th century, and telescopes became the bomb. German astronomer Simon Marius got busy using these new gadgets to observe Andromeda. He spotted its intricate spiral structure, but because telescopes weren't super advanced back then, he mistakenly thought it was just a star cluster, not a whole galaxy. Then, in the early 20th century, Edwin Hubble, an American astronomer, took center stage. He used a fancy 100-inch Hooker telescope at Mount Wilson Observatory to study a certain type of stars in Andromeda called Cepheid variables. These stars pulsate in a regular way, and Hubble figured out that their pulsation periods are linked to their brightness. With the help of Henrietta Leavitt's work, which gave the lowdown on the period-brightness relationship for Cepheid variables, Hubble made accurate distance measurements. And guess what? He found out that Andromeda was way outside the borders of our Milky Way galaxy. It was its own separate galaxy. Mind blown. This discovery totally rocked the boat because people used to think the Milky Way was all there was to the universe. Hubble's findings opened our eyes to the vastness of space and the existence of other galaxies out there, each with its own unique traits and quirks. And Hubble's work didn't stop there. His observations paved the way for a whole new field called observational cosmology. He laid the groundwork for studying how the universe is expanding and even came up with the famous Hubble's law, which tells us about how the recessional velocity of galaxies relates to their distance from us. In the end, the historical understanding of the Andromeda Galaxy is a story of human curiosity, the awesome power of telescopes, and the brilliant minds of astronomers like Edwin Hubble, who changed our view of the cosmos forever. It's like a cosmic adventure that keeps on giving. Alright, let's dive into the nitty-gritty of two super important tools in astronomy, photometry and spectroscopy. These techniques give astronomers all the juicy deets about stars and galaxies, helping us understand what makes them tick and how they do their cosmic dance. First up, photometry. This technique is all about measuring the brightness or intensity of the light coming from celestial objects. Think stars and galaxies, they're the stars of the show here, pun intended. Astronomers use fancy instruments like photometers or CCD cameras to collect and analyze light at different colors or wavelengths. Photometry spills the beans on how bright stars and galaxies are. It helps astronomers figure out their intrinsic brightness, which is called luminosity. By looking at the intensity of light at different wavelengths, we can estimate the total energy they're throwing out there. Then there's the idea of flux and magnitude. Flux is like how much light energy reaches a certain area in a certain time. And magnitude? Well, it's a way to measure how bright objects are. The lower the magnitude number, the brighter the object is. Photometry also lets us snoop around for stars that like to change things up. You know, variable stars and those binary systems where they play peekaboo with each other. We're like cosmic paparazzi, keeping an eye on their brightness changes over time. And let's not forget distance estimation. Photometry is like our cosmic tape measure. By comparing how bright stars and galaxies appear to us with what we know or guess about their luminosity, we can figure out how far away they are from good old planet Earth. Next on the list is spectroscopy, the Sherlock Holmes of astronomy. This technique is all about analyzing the light emitted or absorbed by celestial objects. Just like a prism splits light into all its colors, spectroscopy disperses light into a spectrum with distinct lines that give us the dirt on the object's properties. The spectrum is like a secret code. It tells us what elements are hanging out in the object's atmosphere or interstellar space. Each element has its own special signature of absorption or emission lines at specific wavelengths. And here's where it gets really cool. Spectroscopy can tell us if an object is coming or going. When something moves away from us, its light gets stretched out, and we call that redshift. If it's coming closer, we get a blue shift. It's like a cosmic Doppler effect, but instead of hearing an ambulance siren, we're seeing the shift in spectral lines. The redshift and blue shift help astronomers figure out the speed and direction of an object's motion relative to us. It's like cosmic detective work. So there you have it, photometry and spectroscopy, two essential tools that help astronomers uncover the secrets of stars and galaxies. They work together like cosmic BFFs, giving us a deeper understanding of the amazing wonders in the universe. It's like being on a never-ending cosmic expedition, and the more we learn, the more our minds are blown. Let's get into the mysteries surrounding the Andromeda Galaxy, or M31, like the intriguing gamma-ray radiation and the enigmatic dark matter that might be lurking within. First up, gamma-ray radiation. It's like the wild child of electromagnetic radiation. These gamma rays are super high energy and come from some of the most intense and explosive events in the universe. They're way more energetic than visible light or even X-rays and can travel through space like cosmic ninjas. Special telescopes and detectors are needed to catch these elusive rays in action. Now, let's talk about dark matter, the ultimate cosmic hide-and-seek champion. Dark matter is this mysterious stuff that doesn't play nice with light or any other electromagnetic stuff. It's like a ninja of the cosmic kind, completely invisible to regular telescopes. But even though we can't see it, we know it's there because it has this sneaky way of influencing the stuff we can see, like stars and galaxies, through its gravitational pull. So, here's where it gets interesting. In Andromeda, scientists have detected gamma-ray emissions. These gamma rays are thought to be produced when cosmic rays, energetic particles zooming through space, interact with the gas hanging out in the galaxy. Now, this raises the big question, could dark matter be involved? One leading idea is that the gamma rays might be produced by the annihilation of dark matter particles. According to what we think we know about dark matter, it's made up of these mysterious elementary particles that are stable and electrically neutral. When two dark matter particles bump into each other, they might annihilate, and one of the byproducts could be these high-energy gamma rays. But, hold on a second. As exciting as it sounds, these gamma-ray emissions aren't direct proof of dark matter in Andromeda. We need to do more digging and investigating to be sure. Scientists are looking into other possible explanations too, like interactions between cosmic rays and gas, or the contribution of known gamma-ray sources like pulsars or black holes. The dark matter mystery is one of the biggest puzzles in astrophysics. We think dark matter makes up around 27% of the stuff in the universe, way more than the 5% made up of ordinary matter, the kind we can see. The rest is this mysterious thing called dark energy, which is driving the universe to expand faster and faster. Cracking the code of dark matter is a major goal for cosmologists. If we can confirm its presence in Andromeda, it would be like finding a hidden treasure trove of cosmic knowledge. It could give us precious insights into how dark matter is distributed in galaxies and the universe at large. So, we're gonna keep our cosmic detective hats on, and with more observations and clever science, we're determined to reveal the secrets of dark matter and its cosmic role. Let's talk about the fascinating ring of dwarf galaxies that surrounds Andromeda, the cosmic giant also known as M31 or Messier 31. It's like Andromeda has its own entourage of smaller companions. First off, what are dwarf galaxies? Well, they're like the little siblings of the larger galaxies, such as Andromeda and our Milky Way. They're not as bright or massive and have fewer stars, but they come in various types, like dwarf elliptical, dwarf irregular, and dwarf spheroidal galaxies. Now, the discovery of the ring of dwarf galaxies around Andromeda was a big, eureka, moment in astronomy. Scientists noticed this unique arrangement of small galaxies encircling Andromeda during their observations. So, what's going on with this ring? It's all about the gravitational dance. Andromeda's gravitational pull plays a significant role in shaping this feature. Imagine this scenario: smaller dwarf galaxies, probably minding their own business and following their independent orbits in space, got caught up in Andromeda's gravitational grip, like it said, "Hey, come join the party." Tidal forces, another key player, also come into play. As these dwarf galaxies orbit around Andromeda, they experience variations in gravitational forces, called tidal forces. This cosmic tug-of-war can stretch and distort the shapes of the dwarf galaxies, making them elongate along their orbital paths. This ring of dwarf galaxies around Andromeda tells us a lot about the history and evolution of galactic systems. It's like a galactic buffet. The process of larger galaxies gobbling up smaller ones, known as galactic cannibalism, is common in the universe. The ring of dwarf galaxies likely formed from past interactions and mergers with Andromeda's smaller companions. What's even cooler is that our own Milky Way has a similar feature called the Leo ring, so it's like a galactic trend. This similarity between Andromeda and the Milky Way suggests that interactions and mergers among galaxies are pretty common in the cosmic neighborhood. Studying the ring of dwarf galaxies in Andromeda and its counterpart in the Milky Way gives us valuable insights into the dynamics and gravitational influences that shape galaxies. It's like uncovering the cosmic dance moves that galaxies have been doing for billions of years. So, there you have it, the captivating story of the ring of dwarf galaxies around Andromeda, shedding light on the relationships and interactions between galaxies and the incredible processes that have shaped the cosmos throughout its vast history. The universe is a big old playground of galactic wonders, and we're just scratching the surface of its mysteries. Let's take a look at two game-changing space telescopes that are set to push the boundaries of our understanding of the universe: the James Webb Space Telescope, JWST, and the Dark Energy Spectroscopic Instrument, DESI. First up, we have the James Webb Space Telescope, the ultimate successor to the famous Hubble Space Telescope. This bad boy is a collaboration between NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA, and it launched on December 25, 2021. JWST is like an infrared wizard. It's all about seeing the universe in the infrared part of the electromagnetic spectrum. Infrared light is super useful because it lets JWST peer through cosmic dust and observe the earliest galaxies that were born way back in the early universe. We're talking a front row seat to cosmic evolution. With its super-sized primary mirror, 6.5 meters in diameter, that's like the size of a small room, JWST is a high-resolution champ. It can snap stunning images of distant galaxies, stars, and all sorts of cosmic wonders. But wait, there's more. JWST has some impressive spectroscopic skills. It can analyze the light coming from celestial objects and tease out all kinds of juicy details like a star's chemical makeup, temperature, and motion. This gives astronomers a sneak peek into the dynamic world of galaxies and their evolution. JWST's observations are expected to answer some big cosmic questions, from galaxy formation to the early universe. Its ability to catch faint infrared light from far-off galaxies will let scientists study the very first galaxies that came into existence, giving us a glimpse into the cosmic baby steps of the universe. Now, let's talk about the Dark Energy Spectroscopic Instrument, or DESI, located at the Kitt Peak National Observatory in Arizona, USA. DESI's mission is to unravel the secrets of dark energy, the mysterious force that's driving the universe to expand faster and faster. DESI is like a galaxy detective. It uses optical spectroscopy to study the light emitted by galaxies. By splitting light into its different colors or wavelengths, astronomers can analyze the spectra of millions of galaxies. It's like having a massive cosmic census at our fingertips. DESI's gonna conduct some galaxy surveys that are out of this world. It will measure the distances to countless galaxies and gather crucial info about their properties, like their chemical compositions, formation histories, and movements. What's the big deal, you ask? Well, DESI's galaxy surveys will give us a bird's-eye view of the universe's large-scale structures. This means we can get a better handle on dark energy and how it shapes the web of galaxies across the cosmos. Together, JWST and DESI are a dynamic duo that's gonna shake things up in astronomy. They're gonna open new doors for our understanding of galaxies, the early universe, and the mysterious forces that govern the cosmic dance. The universe is about to reveal its secrets like never before, and these space telescopes are our cosmic keys to unlock its wonders.